So let's talk about what happens when we have more than one mass in a system. And in particular, we're going to be talking about pulley systems. So we have two basic pulleys. We have an Atwood machine, which is just a pulley with two masses on it tied together by a string, so that the tension that lifts one and causes one to fall down is they're equal to each other because they're pulled tight. So the problem is that when we have these, we need to make sure that they both have the same acceleration. So we can't say one is going up at positive 2 meters per second squared and one's going down at negative 2 meters per second squared. We have to have them both have the same positive or negative acceleration. So what we do is we decide which way it's going to rotate, and the direction of rotation for each mass is positive. So for example, if mass 2 is rotating down, then down vectors will be positive. And if mass 1 is rotating up, then up vectors will be positive. The other pulley system we have is a modified Atwood machine, which is just a box sitting on the table. So it's going to rotate around like this. So the heavier mass is going to rotate down. So down is positive for it. And the box on the table is going to rotate to the right. And so right is positive for it. So let's consider this Atwood machine, and let's say that M1 is 50 kilograms. So let's find its weight. 50 times 9.8 is 490 newtons. And mass 2, let's say that is 20 kilograms. So Fg2 is going to be M2 times gravity, or 20 times 9.8, which is 196 newtons. And since M1 is heavier, it's going to rotate down. So down will be positive for it. And since M2 is lighter, it's going to rotate up, and up will be positive for it. Both of them have tension and weight, but notice that I'm designating one as M1G and one as M2G just to distinguish between the two weights. So they only have two forces acting on them, but when we add them up to write the net force equation, we're going to make sure that we add the vectors taking into account the direction system for each mass. So the next thing we're going to do is we're going to isolate each mass. So we're just going to think about mass 1. Remember, mass 1 is 50 kilograms, and it is rotating downwards. So it goes down because it's 50 kilograms. So it has Fg1, which is 490 newtons, and it has some tension on it, but we don't know what that tension is. But we do know that it's in the opposite direction, so it's going to be a negative value. So if we were to write all the forces that cause M1 to accelerate, well, Fg1 minus the tension, or plus negative tension, causes M1 to accelerate. So Fg1 is 490 newtons minus tension equals 50 kilograms times A. For mass 2 is going to be moving upwards. So up will be its positive direction. Tension will be the positive force acting on it to move it up, and its weight will be slowing it down. So all the forces that make mass 2 accelerate are going to be tension minus its weight in this case, because its weight's what's slowing it down. And that would be tension minus 196 newtons equals 20 kilograms times A. And then finally, the total mass system. Well, what the heck is that? So remember, we have this pulley, we have this mass here, and this mass here. The total mass system is thinking about this as a blob. The tension is part of the blob. So it's not going to be drawn in the system. We're going to think about all the forces that are causing it to rotate and to slow it down. Well, the first one that's causing it to rotate is Fg1 because it's really big. but Fg2 is slowing it down. So if we think about it, Fg1 is causing it to accelerate, and Fg2 is causing it to slow down. So the net force that makes the total mass accelerate is Fg1 minus Fg2. So that would be 490 newtons minus 196 newtons equals 50 plus 20, which is 70 kilograms times A. So 490 minus 196 is 294 divided by 70 kilograms is going to give us an acceleration of 4.2 meters per second squared. So it has an acceleration of 4.2 meters per second squared. Notice that this is the easiest system to analyze to find the acceleration because you don't have to worry about tension. You have one unknown, acceleration. Now, if I want to find the tension, I can just go over here. Tension minus 196 newtons equals 20 times 4.2 meters per second squared. T equals 88.20 times 0.2. 84 newtons plus 196 newtons, which is 280 newtons. So the tension is 280 newtons. And since it's the same, if I use the other equation, I'll find the same relationship. All right. So let's look at a modified. So we're going to do the same thing. We're going to have 20 kilograms and 50 kilograms. Okay. But what's going to happen is that this is going to rotate to the right. This is going to rotate to the left. Now notice that since it's rotating to the right and it's on the table, mass 1 is going to be a little different. So let's talk about that. So mass 1 is actually sitting on a table. I'm going to draw the table in there. So it has some weight, but the weight is being balanced by the normal force. So we don't really need to worry about that, okay? It has weight being balanced by normal force. These are canceling each other out, and the only force that's causing motion in the x direction is the tension. So the only force that makes mass 1 accelerate is tension. And for mass 2, it's accelerating downward. It has weight that's making it accelerate downward, and tension, which is negative. So in this case, the only forces that are affecting its motion, making mass 2 accelerate, are its weight minus its tension. Well, its weight is 490 newtons minus tension equals 50 kilograms times A. Can't really do much with these, right? So, for the total mass system, right, we have right here, tension is part of that. It's internal to it, so it's just part of this big mass system. We only have one force that's causing its rotation, and that is the weight of mass 2, right? There's no friction on this, and the weight is being bounced by the normal force, so there's nothing dragging it. It's like it's on ice, the one on the table. So the only force that's causing it to accelerate is F2. F is making both of the masses accelerate. So Fg2 equals m total times A. Well, Fg2 is 490 newtons. and this is 70 kilograms. So A is going to be 490 divided by 70, which is 7 meters per second squared. And we can go back to one of our tension equations. Let's use this one. 490 newtons minus tension equals 50 kilograms times 7 meters per second squared. So this turns into 350. So what I'm going to do is I'm going to subtract 490 from both sides. So negative T equals negative 140 newtons. And actually that becomes 140 newtons.